Hi, thank you for the great introduction. So I'm Tomasz Żelawski. I'm a software engineer at Software Mention, and I work in the React Native open source team. And today I want to talk to you about React Native-worklets, which I maintain and allegedly created. But before we go into it, we need a little reminder of what exactly a React Native app is. So, in simple words, a React Native app is just a standard native app, which means that it has a main thread, also called the UI thread. But what makes the React Native app unique is that it runs some JavaScript code on another thread called the JS thread. And the JS thread handles the React tree, which is then translated to native character views and rendered on the screen from the UI thread. And, you know, my phone has 6 CPU cores, and this only takes 2. So, how do we use the remaining 4 cores? Well, the fact is that some JavaScript code is actually a lot of JavaScript code. It's literally the whole of our app, consisting of many unique parts. So let's single out some of those parts. What do we have there? First and foremost, we have the management of the React tree, so rendering your views, your hooks, and translating some of the JavaScript into the native components. Then you have animations, so using libraries like React Native Reanimated. You also have gestures, so probably React Native Gesture Handler. You definitely do data fetching and processing, general API calls, REST APIs, and so on. You might also do some heavy calculations, cryptography, encryption, if you're doing like a chat app that has end-to-end security until it's banned everywhere. You might also do camera frame processing with React Native Video Camera Library and directly access the GPU with React Native Web GPU. And the problem is that all of those tasks sit on this single core on the JS thread. And we still have all of those to use. So it's time to wake them up. But how? The execution pipeline in React Native is quite simple too. So we have that JS thread, which has all of these tasks in the JavaScript code, but it cannot execute these tasks on its own. It needs a tool that can understand the JavaScript code. So this tool is an instance of the JavaScript virtual machine, the block of memory that understands JavaScript and can do some stuff with it. And in the case of React Native, we call this virtual machine is the Hermes virtual machine, which in short we call just the Hermes runtime. And I personally like to call it the React Native runtime, because this is the React Native, the runtime created by React Native, and this is where React lives. So, going back to our course, we would ideally take all those tasks from the JS thread and split them among our cores. And then execute all of those on the same React Native runtime. But this is obviously not possible because JavaScript is single-threaded. It cannot be accessed from multiple threads at once. I like to, Yes, so what do we do with it? Well, it's time to get creative. And in our creativity, let's start small. Let's start with priority tasks. And the priority tasks of your app are animations and gestures, because this is the direct interaction with the user, which has to be fast and responsive. So we have, for the moment, the handling of the React tree, our animations and our gestures, our single core and our single runtime. And to offload those, we must offload those to the UI thread, because this is the thread that has the asynchronous access to the rendering layer and which gets the touch events first. but we are still we still have the same problem. We have only one runtime. So let's just create another one and call it the UI runtime. And then we can execute the React tree on the React Native runtime and then execute the animations on the UI runtime. Sounds great in theory, but there's a problem. And this problem is the JavaScript bundle. Because when React Native loads, it loads all of your JavaScript code into the JavaScript bundle and puts this bundle onto the React Native runtime. And unfortunately, this bundle cannot be moved in any way to the second runtime. Even a single function from this bundle cannot be taken to the UI runtime. And I think there's a great analogy to trying to move this bundle from one runtime to another. It's like moving a file between two computers like this, which I really think was possible, but, well, I mean, your, I don't know, aunt or maybe mom tried it one day, and it didn't work, and you had to explain why is this not possible. But it would be great if it worked. And this problem is why worklets were invented as a concept in 2020. But what is a worklet? And what is the ever enigmatic worklet directive in a function? So, if we go to the docs, we can find the following definition. A worklet is a short-running JavaScript function that can be moved and executed across different runtimes. But how is that possible? We just said a second before that we cannot move a single function from one runtime to another. Well, it started with a simple Bubble plugin. Bubble is a tool that does some transformations of your code before it's loaded into the bundle. And this plugin was recently renamed with the release of the React Native Worklets library to Worklets Bubble plugin. And you are pretty much familiar with it because one thing reanimated in Worklets 2 are famous is due to its errors, and this error is pretty famous, failed to create a worklet. But what does the plugin actually do? We have a simple code that uses React Native Reanimated, and we have use animated style with a worklet inside. And the transformation that the plugin does is the following transformation. So the function from the use animated style is extracted out, and a code property is appended to it with the whole code of the function itself. And then this function is passed to use animated style as a parameter. And the actual transformation is actually a bit more complicated, but the key component is still that code there, the whole code of the function. Because we cannot move a function between runtimes, but we can move a string. And if we can move a string to another runtime, we can then evaluate it there and run it. And this is how we can do anything on the UI runtime from the React Native runtime with worklets. And this is how reanimated and gesture handlers have been doing this for years, and this is why they are so popular and effective. Okay, but these were only the priority tasks, the gestures and the animations. What about the other tasks? Well, this is a bit more complicated, because in general we are now talking about using libraries in worklets. And passing strings of functions just won't do it here. This is because in case of, for example, reanimated, it has its functions marked with the worklet directive. So we have access to the code of that function. But if we look at more general, libraries, like Lodash or Axios, we can see that there is no mention of worklet in the code, meaning that we have no strings to move, no code to execute on the UI runtime. And to solve this problem, we actually have to take a step back. because we said that we can't move the bundle between the runtimes. Well, what if we could meet the bundle mode? The bundle mode is an experimental feature in react-native-worklets. It's experimental because its setup is pretty complicated, but it's actually stable in production, and you can try it in your own app. And what it does, it integrates deeply with the code and tools available in React Native to access the JavaScript bundle before it's loaded to the React Native runtime and to share it across as many runtimes as we need. So now we can have a background thread with its own runtime, a separate runtime called a worker runtime, and pass the bundle there. And so how does it work if it doesn't use strings? Well, let's say we have the following example. We have a simple universe.ts file that has some function called load_universe that uses Axios to do an HTTP request. And then we have our component app.tsx, which has a export default function app which uses load_universe. And what we want to do, we want to offload this request of load_universe to another runtime. So we add a worklet directive and add an import of create worklet runtime and run on runtime from React Native Worklets, create that runtime, and finally run load_universe on that runtime. But well, here's another problem. How do we link the functions? Because we have two runtimes. Each of them has the load_universe function, but how do we tell that if I want to invoke load_universe from one runtime, it executes exactly the same load_universe on another runtime? How are we linking the bundles? And to figure out how to link them, we must understand the structure of the JavaScript bundle in React Native. So going back to our example file, and this is how our code looked initially. And if we look into the bundle it produced, it's pretty complicated. It's actually a simplified version of the bundle. The real bundle is usually hundreds, thousands of lines long, weighing around up to, I don't know, like 50 megabytes. So this is only 1,300 lines. And the key elements that we have here is that in the beginning, we have some initialization, which is not important to us. But in the latter part, we have the __d, and in the last line, __r invocations. And what are those? Well, they are actually define and require. Define defines a module in a lazy fashion, and a module in the bundle terms is just a single file. As we can see, there's the define of app.tsx, define of universe.ts, and the require is require call just like in Node API, which takes a module and invokes its code. And these are global functions, meaning that we can use them from any place in the code. And you might already know where we are going from here. So, yeah, the universe, and this is also the module for the Axios index file. So, if we look into the define, we can see that it actually has our code, our call of load_universe inside function app. It's transformed to a format that's acceptable by React Native, but this is basically the same thing. And if we look at this little number in the define, this one, this is the module ID of our universe.ts module. And this is great because this module number is going to be the same on all of the runtimes, in all the bundles, meaning that module 1 in the React Native runtime is the same as module 1 on the UI runtime and same as module 1 on the worker runtime. So that way, we can call the module 1 on one runtime or another, and it's going to be the same code. But how do we obtain this number? Because this is in the bundle. We don't have it while we are writing the code. Well, turns out that actually there is a possibility to do that. So if we only could do the following transformation to add a module ID property to our load universe, we can call require.resolve_weak and then pass the name of the module. It looks a bit silly because this is the university's file, but this is how you have to do it. And require_resolve_weak is a function exposed by Metro, which lets you get the module ID. So with all of this, we get the effectively just load universe module ID equals 1. And the 1 is a number which can be passed to C++. So now react-native-worklets can just write a method in C++ called getModuleID, which gets a worklet and gets property module ID from it and returns that ID. And then we can implement a C++ method in worklets, run on runtime, which takes a target runtime and the module ID, obtains require from the global object via the __r, as we saw in the bundle, and call that require function with the module ID. And this is how we invoke load universe on another runtime. And we went from this to this, and with the bundle mode to this, using all the cores on the physical device instead of just one, with our tasks evenly distributed, and this is thanks to worklets everywhere. And I really think this is the future of React Native, because with React Native worklets and the bundle mode, we can get the missing piece in React Native, the one that has been missing for years, which is web workers. And this is all from me. Thank you.
Tomek once said that worklet is a high-level spell. Not everyone has to know it. But at least there's a tutorial now, so that's cool. Do we have questions, maybe? We have some time for questions. I believe there are many questions, but we're open? No? There's one. There's one. The gentleman in the back.
I recognize his face.
You do?
Hey there, awesome presentation, thank you very much. I wonder about the memory footprint of the JavaScript bundle, and that from the second runtime you are accessing the same bundles, the same module ID. But is the bundle like copied to the second runtime, or is it referenced? So that when you have, essentially what I'm asking, when you have 6 cores, will you have the same bundle loaded 6 times in the memory, or it's going to be one bundle?
So we do it the way that we do not copy the bundle, but some internal implementation is still down to Hermes. So, for example, the bundle as a code is shared just once, so there are no copies. But in terms of executable code, at the moment, if you don't use static Hermes, it's going to be duplicated, but this is not that much of a memory footprint from my measurements. But if you do use static Hermes, then the bundle is just a single instance shared across all runtimes, which is our goal, to have no code duplication, no memory duplication.
All right, thank you.
Hi, first, really amazing stuff. It's like Einstein, so. I have a question, maybe a little more basic ones, but do you have any practical mindset advice in terms of when do I think when should I think to actually start implementing worklets? Because obviously, if everything works nice without worklets, we're not doing it. But what are the signs that I should try to actually implement it and it can be beneficial?
Well, I think it's really use case dependent, because worklets are supposed to be like a building blocks for more, let's say, fine detailed usage. But for example, I was playing with a React Native Web GPU, and in situations when you have like some, I don't know, rotating cube or rotating element that is rarely changed, or changes to it are irrelevant to the user input, then you can offload it totally to the other thread and free up the JS thread. So you might get rid of some performance issues. It really comes to how your app works, because if your app is performant enough, then there is no reason to offload anything. But if you are struggling and you are already trying to optimize something, so I know your list works badly, so you are going to legend list to get that few FPS back, maybe you need to offload some web fetches or general API calls or whatever. What do you do? What makes your list slow? So I think it's hard to give a general guideline. You just need to experience, not experience, experiment.
Okay, thank you.
Last one?
We have one more.
Yeah. In the middle.
Hi, awesome presentation, really appreciate it. Wanted to ask which types of values can you actually send different values between worklets, and which value types are not supported or transferable?
Yes, so a JavaScript virtual machine is a block of memory that's very coupled together, so you can't just take one element and pass it to other runtime. You're going to have an exception. But there are methods to serialize some data. So for example, like numbers, strings can be moved without any problems. Objects can be serialized and deserialized. If you have more complicated use cases, like a self-referencing object like with recursion inside, this can be done, but it needs some implementation. Functions can be moved in any way. But if you think of like all of like standard objects that it use, some maps, sets, arrays, and so on, they can be moved without any problems. If you have a custom class, so you have a class on one runtime and you want to move an instance of it to another runtime, you would need to tell how to serialize it. So turn your class into just an object, and then turn that object back into a class instance on another runtime.
Okay. What about array buffers? Like
yes,
images?
they work right off the bat.
Okay, cool. Thank you.
Great questions. Thank you. Thank you, everyone. Thank you, Tomek.
Thank you.
Please.